You see it, right? Okay, it says we have 100 samples, and then the mass of each sample in grams are given in here, so 100 values. Apply the chi-square test to examine whether the data set formed by the set conforms a Gaussian distribution or not. So for the test of Gaussian distribution, you have to make a table like this in here, okay? So why do we do this table? Because at the end you will have to sum up all of these numbers at the last column and then compare the result with the results of the table for chi. Okay, there is a table for chi. Where is it? Chi-squared table. This table 4.2. So these are values for a Gaussian distribution. You know it, right? What are the k? What is k in here? Degree of freedom, right? So we will understand what is the degree of freedom for these 100 values. That's right. We have to solve. And there are some numbers after chi-squared. For example, this is 0.995, and these are smaller numbers. So these are the level of significance for us, the alpha. Okay, so alpha is important for us, and then the degree of freedom is important for us. We have to do some mathematics until we get some results from the data that it's given to us, and then compare that data, compare that value with the values of chi-squared in this table. So let's start by just copy and pasting the data. These are the values that we have. So I just copied and pasted. You don't have any problem with copy and paste, okay? So in this column you have the samples. So let's go. Can you see the Excel? There is no problem with the. Okay. We have row 101. So all the data that we have is 100. So the count is 100. 100 data. So in this cell, I just wrote the Sturgis formula to understand how many beans that should I use in histogram. So it gives me 7.6 because you have to take the logarithm of 100 and 3.3 multiplied by that plus 1. So it gives 7.6, and if you round it, it gives you 8 number of beans. So in 8 number of beans, what I'm doing in here is not like choosing this data and then go to insert and select the histogram, because this histogram is not giving us the appropriate width, okay? And we cannot play with it inside the Excel. We cannot play with it because bean width, if you just play with the bean width, let's say you say it's 5, I don't know, it automatically adjusts the start and end of this each bean, okay? We don't want it like this automatical, we do it manually. So you just remove it, and I'll let you know how to plot histogram yourself. So this is the histogram I just plotted. It's not definitely like similar to the histogram in Excel, automatically generated histogram in Excel, but we will make it similar to that. So we found 8 number of beans, and we want to find the minimum and maximum of these samples. So this is the formulation: minimum of the column, and then for the maximum of the column, you see the formula in here. So the bean size would probably be the maximum minus minimum divided by the number of beans. So this 8 number of beans, the bean size is 4 point something, and you round it again, so you just consider 5 beans. Sorry, the width of each bean is 5 grams, because these are grams, okay? 487 grams, and these. So let's start and see what is the minimum. 480. So I just started from 479.5 to include 480 inside this first bean. Is it okay? So if you add 5 like this formula, so this is the start number, and then after this starting, I just add 5 by 5 to each number. If I go like this until 519.5, these are how many beans? These are 9 beans. So I have to exclude the first one. This would be 8 beans. To find how many data is there inside each bean, you have to use a formula, and it's a frequency formula. Okay, how do you do this? You have to write such a formula. The frequency inside this blue one is the data that you have, so it starts from A2 to A101, and then you have to decide in which increment, in which sections you want to put these frequencies. So these sections are actually your beans, right? When you write this formula for all of these beans, then you will find the frequency of your data. So it means that this 5 is the number of samples that are within 479.5 to 484.5. You will find 5 numbers. And then if you just select these and insert a bar, you will find the histogram. Okay, this histogram, the x-axis is not looking like the histogram of Excel. So how do you make it similar to that histogram? I just do a trick in here. I want to write in here for the first bean. I want to write this bean is from, for example, 479.5 until this number. I want to write instead of this 1 here, I want to write this number to this number, just like Excel gives to you. How do I write it? Like this. There is a concatenate in Excel. So concatenate means to sum up in strings. Okay, so you have one string and you want to glue it to another string. Okay, sum up strings. So you concatenate it. Concatenate what and what? Concatenate this number, comma, I want to put a dash sign, so this is a dash sign, and then the second number. So it gives me 479.5 until 484.5. So if you just take this and go to the last cell, you will have the ranges for each beans. Now it's time to put this, instead of 1, 2, 3.4, 5, you go in here, right click, and then select the data. Then in the horizontal axis, you will select the new axis, this axis, and OK, and OK. Understood? So this is much more similar to the automatically generated histogram in Excel. You can decrease the gap width as well. Let's try it and see if the width okay. It starts from 480 till 486.3.
Biz 479,5'tan aldık da zaten bunu binalara saymadık.
It's been 20 minutes that I'm trying to tell you that there is a difference between this and that. Okay?
Can I say a trick?
Yeah.
I get that you manually scroll this
Mm-hmm.
graph, and I found that trick just trying myself. If we answer the options of that automatic
Okay. These are the options.
And select number of beans,
Okay.
8, and I select overflow bin, underflow bin.
Okay.
Then underflow bin is 484.5.
484.5.
And the other one is which value? I can see 514.5.
Okay.
Yeah. There's something good.
484.5, right? Is it true?
The opposite now.
484.5, 500, 500, right?
Yeah. Now it's true.
Okay.
Yeah. Same thing now.
You will get the same thing, right? But to obtain these numbers, again, you have to first obtain the numbers. You just read these numbers from my graph. I generated this graph.
We don't know the in values, right?
Huh. Yeah, exactly. The problem is that you don't know the bean values. If you know the bean values, yes, you can set it inside the options, in these options. But do you know the bean values? First, you have to know the bean values and then insert it. So, by this you just found out that there are two ways to make a histogram.
Actually, three.
Actually, three.
I had a tool that data analysis tool added on my Excel, so I can make a customized histogram.
Yeah, there are always some macros in Excel, and you can use those macros in Excel. But if you don't have any macros and you have to do it by yourself, there are two ways. Okay, of course you can use other macros to automatically generate whatever you want. So this is histogram. There is no problem with the histogram. Our friend question is about these numbers n and n prime and these things. What are these? First of all, for the chi-square test, you have to find the optimum number of beans. What does it mean, optimum number of beans? Right now we have found 8 beans, right? Let me take this and put it to here. We said that we have 8 beans. These are the beans. So we have to check if we have enough number of data inside each bean. How do we check it? There has to be 4 and above number of data inside each bean. So I'm checking it with this. It gives, if the value of this frequency is greater than equal to 4, it returns true. If it is not, it returns false. So supposedly there are, all of these are true. Okay, so in each bean we have enough number of data. So next step is to calculate the average and standard deviation of the data that you have. You can do it, right? Okay, and then start forming this table. This table is going from here to here. What is this table? So first it starts with x. What is x? X is the maximum number of the individual bean. So maximum of this bean is 484.5. Maximum of the second bean is 489, and it goes like this until we reach the maximum of the last bean, 519.5. So this is our x. Understood? Then you have to find your z. Z has a formula. The formula is x minus average divided by standard deviation. I wrote this formula in here. Okay? So these are the values for z. Next, you have to go to the z table and find f of z. So what is f of z? Where is the table of z? Is this the table of z? No, this is the table of chi-squared. So let's go and find the table of z. Okay, this is the z table. I want to find the value of minus 1.79, right? You have to first round to 2 digits because it gives you until two digits, right? This table. So 1.79, and it is minus. Minus means what? F minus z is equal to 1 minus fz. So fz, when z is equal to 1.79, 1.79 is 0.9633. So I have to write 1 minus 9633, right? So this is the first one, and it goes like this until the end. You want me to find one more? No problem with z and f of z. Okay, next you have to find this number n prime I. What does it say? What is n prime I? This has a formulation in here. This is P3, which is your value of Fz times the count of your data. So what does it say? It says that if your data has a Gaussian distribution, okay, you found that from this table the Fz variable for this bean is this much, 0.0367. So times the number of your data, it will give you the amount of data that would be inside this bean. Okay, out of 100, it means that you have to multiply each one by 100, right? Okay, but what about this one? If you multiply it by 100, it gives you 11. But there is something else in here. Why?
-3.
Yes, exactly. Because each bean consists of the beans that are in the left-hand side of that bean. So you have to take out the number of those beans as well. So what I did in here, I did multiply this value of fz by 100, but subtract the value of the bean that is before that bean, this bean, the current bean. What about this one? You see in the formula, there are 2 beans that I had to subtract. What about this one? 3 beans. And the last one, actually, all of the beans above, I have to subtract the values. So this is n prime I, and then again, I have to round it up until the first digit. I did it in here, in this column. And then ni. So what is ni? Ni is the number of beans that I just found. These are the ni, frequencies, number of beans. So, I found n prime I and ni. What I'm left with is nothing but a formula. You have to subtract n prime from n, and then you have to square it, and then you have to divide it by n prime, and sum them up. When you sum them up, you will find 1.9599 or 1.96. Okay, so this is the chi-squared for your data, 1.96. Now we have to go to chi-squared table. Okay, what do we have in chi-squared table? We have a bunch of k from 1 to 100 and this significance, right? Significance things. So what is our k? The book says it is 6 because you normally consider the number of beans as your k. Minus 2. What are those 2? Yes, you just manipulated your data. You have a raw data, 100 data. This is a fact, okay? But you just manipulate your data by first getting the average of that data, because you don't know that the true value, that the true average is the same as this average that you just calculated, okay? So this is one manipulation, and the second one is the standard deviation of that data, because again you don't know if the standard deviation is the same as the true standard deviation if you get, for example, 10 billions of data. Okay, so because of these two, you have to subtract number of beans, 8, from this 8 minus 2, it's 6. So you go to row number 6, and then you have to find the value of chi-squared that you just obtained, 1.96. So 1.96 is a number between this and this, right? So you can say that I have more than 90% confidence that my data is Gaussian distribution, or the Gaussian distribution of this data with I'm confident that it is between 90 and 95%. Understood? So let's have a break, because some of you are sleeping. Come back, and one of you come and solve the next example. Just explain it like that I explained. Let's have a 5-minute break, 10 minutes break. Probably go and take some fresh air and water. Okay, tell us how to do it.
So I think first I need mean. So I'm
Okay.
going to find the mean.
Okay.
So I take average common, then select all of the data.
Okay,
Then I can find it like this.
okay.
Then I think I need sigma, right?
Standard deviation.
Yeah.
Okay.
So to find it, first of all, I will find the deviation.
Can you write the Excel formula to find the standard deviation? Don't do the deviation and the squared and stuff.
Huh?
Okay.
Yeah.
STV,
Yes.
EV.
Okay. Just I will directly say sigma. So
Okay. Sigma.
equal to ST3.
Okay. Which one do we use? P or S?
I think.
For a limited number of
S.
data, we use S.
Mhm.
Okay.
Then select all the data
Yeah.
again. Yeah, we find like this.
Okay.
Then I think I need K,
Uh-huh.
which means degree of freedom
Degree of freedom. Okay. Where do you get K?
from
From where?
the total data count minus 1.
K comes from the total number of beans minus 2.
Hmm.
So, total number of beans, you have to find the beans first.
How can I find it? By
Histogram, right?
histogram. Hmm.
So, before we have a formula, a Sturgis formula, right? Sturgis.
Hmm.
Yeah.
So first I use it, but what was
1 plus
1 plus
3.3
log
log times log 10 of count of data. How many of data we have yet? We have. Okay.
I think it's true.
Yeah. So we have 7.6
What should I name this?
number of beans from the Sturgis.
Okay.
The Sturgis. The Sturgis. Okay. Then if you round it, it will give us 8, right?
Yeah.
So we'll move on with 8 number of beans.
Mm-hmm.
Now you have divide the beans or the way that you just told me.
I
Do
did.
it like that.
Okay. I can copy from here, I think. For the win with.
Okay,
So-
but if I ask you
India.
in the exam, then you cannot do it, right? Probably I'll ask you to bring your laptops. Do you have laptops? All of you? You don't have. I'll bring my laptop and give it to you. Who doesn't have a laptop to bring in this? Okay, I'll help you in the exam, but I won't help anyone else.
There you go.
So I will make. Can I make a copy from the question? Okay. So then I will just change.
So you just insert a
And
histogram, right? And then you want to change the axis.
yes.
Number of pins to 8. And then overflow is
Cool.
copied from
It should be this value.
479. Oh, 4.
This one.
Okay.
And
The upper
then
band.
yeah. And then 500.
This one is
No.
Why is it not changing?
8. Please use dot instead of comma.
True. Sorry. Now this will also 484.5. Okay, I think now it's correct.
Okay. So now what should we do?
So
We should check for something.
check for greater 4 values
Yes.
for our histogram graph.
If there is enough number of data inside each bean. So inside the first bean, how many data we have? The first bean has three
Three.
data, and the last bean has
2.
two. So this is not enough. So you have to do something.
The hardest thing.
You have to take each two beans together. Okay? So you have to change the number of beans from 8 to 4.
4.
Okay? Each two beans together, it makes 4 beans. Right? Do it for us.
So I think I can copy this and change again.
Yeah?
Okay, I just copy this to here and change the options again.
Mm-hmm. Four beans.
Then I think the shape, the values also change.
And then you have
Here.
to go to the solution to find the numbers.
Yes.
Okay, just find the numbers.
489.5
Okay.
and 509.
509. Okay.
Okay.
This is our new.
These are new beans. Are they okay
Yes.
for us? Because they at least have 4 number of data inside. Okay. Continue, please.
It's the hardest part for calculating this table here.
Okay. I said go to the first row.
Okay. Then we will make the same table, right?
When you want to solve this question, you have to generate your beans because you're going to use the upper limit of each bean to make the x, to make that x, x column. Okay? But right now you don't know it.
You don't know.
Go here and check if this is true in here. So, see this number, is it the same as the first one? And this number,
Yes.
the second, and this number is the third one, and the last one is the upper one, actually.
Yes.
So put those numbers for x.
Just I can write with hand, right?
Yeah.
Okay.
There should be a. Four beans, okay. This
This
is
is X.
Now we told you that you have to calculate z
Yeah.
from x. How?
By this formula, from is equal to X,
X.
but I will just put parentheses.
Okay.
X minus mean
Mean value divided by
sigma. This one, right?
Standard deviation. Sigma.
Sorry.
C.
This one.
Okay.
But I will put just
divided by C2. Now FZ minus 2.13. Go to table. 2.13 means
But
1
1 minus.
minus 9834.
Sorry.
One 42. Nine two two two. Okay. 0.7. 0.7. Okay. This number you already have it in here. 504. Okay. 73. 76, 73. Okay. You have it here on the.
Sorry.
Okay, 2.16, 16, 9846, 46, and the last one is 998, right? Okay, this is FZ, then N prime. This times 100, 100 minus.
One.
Minus, not count. Yes. Okay. And N
We will look from our table.
from the histogram.
Histogram, yeah.
3514.
3,
3, 5, 14, 29, 26.
5, 2.
Okay.
Then
N minus n prime squared. Divided by n prime. Okay. What?
y. Interesting.
Okay.
Okay.
What is the
Total.
total? So 2.38 for degree of freedom equal to
6.
6. Right? This time degree of freedom is 6. For 6 and 2.38.
Between
It's a little bit less than
90.
90.
Yeah.
Yeah. So that time we found the confidence between 99 and 99.5. Now it is something near to 90. This is the difference. You understood? Okay, good. You understood how to do what is it? Interpolation, how to read the tables, and how to solve one example. So I'll give you tons of questions for next week to solve from chapter 4.
Thousands of.
Tons of. More than 20 questions. Kolay gelsin. Görüşürüz. Quiz var haftaya. Teşekkür ederim. Bir puan vereceğim ben sana. Çok iyi yaptın. Sağ ol.
Bundan sonrasında üşendim sanırım.